Hello everyone, I hope you all are doing great. So today is 26th of January when I'm recording it. When you'll watch it, it would be time after that. So happy Republic Day from the past. Anyways, uh, today's topic will be about virtual machines. Most of us have used at least three virtual machines for Liquid Galaxy. So I really hope that you are ready to learn something new. And this is my favorite meme from the presentation. Now, let us understand what is virtual machine. But first, for Liquid Galaxy. Most of us have used three or more virtual machines, and we have used Ubuntu operating system for it. And it is really amazing that how we can simulate an actual computer, a physical machine with its peripherals, storage, networking, and everything, just using our software, which is VirtualBox. So, how these things work? What do they really mean? Are there any different types of softwares? We'll learn everything in detail in this presentation. Uh, Now, let's begin with introduction to virtual machines. So, virtual machine is a emulation of a physical computer that has an operating system and you can run applications on it. Apart from the definition, you can think of it as a hypothetical machine or a fake machine, if you could say that, or an emulation of a computer, just like we used BlueStacks or the emulator in the Android Studio software. You can think of it as something like that. It provides us flexibility. You can run Ubuntu, Kali Linux, or any other kind of operating system or Macintosh, anything that you like, uh, on your Windows device itself. So that's an amazing thing. Then you can use it for development, testing, and deployment that we are already doing now for task 1 and 2. So uh, we know the definition by now that it is an emulation of a physical computer. It has its own CPU, memory, storage, input, output. It allows operating system full access to operating system features. You can run applications on it. Spoiler alert, we'll also be learning about these devices such as CPU, memory, and storage in today's presentation. So stay with me for a while. First, let's focus on virtual machines. These are of two main flavors or types, process VM and system VM. Process VM is kind of a temporary virtual machine, not always, but most of the times. It is there only for one specific process or a specific task, and once it's done, it is automatically vanished. We'll learn about process VM in depth first. Uh, this diagram is a better example. JVM, Java Virtual Machine. Now, anyone who has ever used Java might have heard about JVM. So, uh, let me give you a brief introduction about compilers. Generally, what compilers do is they convert a higher level code, which would be the code that we type in Java, to a lower level language, maybe assembly language or the bytecode, or it could convert it directly into binary. It depends on the type of compiler and the language you are using. So this happens because your CPU that executes the program only understands ones and zeros. It does not understand plain English. So compiler is a converter, you can say. Then your Java source code is compiled down to Java bytecode. You can just consider it as a low level representation of your code. Then something called as Java Virtual Machine pops up. JVM is a process virtual machine. So the hardware that it uses is the hardware that your machine has, the exact hardware that you have. And what happens in a system virtual machine is that all this hardware is emulated or it is faked at a higher layer. So you can look at these simulated machines. These machines will have their separate keyboard, separate mouse, separate CPU, separate RAM, everything separate. And the applications that you run will use this simulated hardware. So let us first focus on process virtual machine. Coming back to JVM, your JVM will pop up and it will only provide isolation to that particular Java bytecode that is meant to be executed. So uh, your bytecode will execute in JVM. It will be isolated and separated from all other system components or other processes that are running, and you will use your host operating system and your host hardware for that. Any libraries or external classes that you refer to are also uh, brought in to the JVM runtime, and it's executed. Once it's finished, the process stops, and with that, the JVM also just disappears. What happens in a system virtual machine is that you separately, boot the machine, then you have to start the application, let's say Liquid Galaxy, then it connects to your other slave machines. So all this process takes place, which would be same if you did that on an actual physical computer with Linux installed on it, like we have in some Liquid Galaxy labs. So this was a high-level overview about system virtual machine and process virtual machine. Now you might wonder, what is this virtual machine monitor? Even I think somewhere here, yes, there is something called as hypervisor. If you might have noticed, it is the layer between these machines and the host OS. So what is it? It is something that we'll see in the future slides. Uh, an example that you must remember about hypervisor is, or virtual machine monitor is, they both are similar things, is that VirtualBox software that we use is a type of a hypervisor. So, a hypervisor is a visualization layer that creates and manages virtual machines by abstracting CPU, memory, storage, I/O, and physical hardware. Again, just forget the definition. Uh, I have, mentioned fake hardware. It has its own memory, CPU, and all. But where does this come from? And in the end, whatever you want to execute, any kind of application or process, you cannot just run it as on a fake hardware, you can say. It needs real hardware access anyhow, because otherwise there is no point of making virtual machines, right? If you cannot run your applications on it. So hypervisor is the layer that stands between your host operating system or the hardware and your virtual machines. It creates the fake CPU, memory, and other things for your virtual machines individually. It manages them, and it gives them your real actual CPUs, execution time, hardware, storage access, memory access, and other things. So we'll learn about it in depth. So there are generally two types of hypervisors. First one is bare metal hypervisor. Let me give you an example first. If you might have heard of Cube's OS, if not, just Google it. It's really cool. What happens is that Cube's OS requires Type 1 hypervisor to run. What happens in Type 1 hypervisor is that you have your hardware, the actual physical hardware, then you do not have the operating system layer in between. So there's just hardware, hypervisor, and your virtual machines. So what happens is that because there is no host operating system in between, you save on a lot of time and efficiency, because there is something called as kernel in an operating system. What is operating system? It's just a software, right? To interact with the hardware, which is a very sensitive region of your machine. There is a software program called as kernel, which is the part of an operating system, and it is responsible for communicating with the hardware or providing instructions to the hardware. So, what happens is that your hypervisor would communicate with your operating system, let's say Windows 11, and Windows 11 will ask its kernel to perform those operations. Then the hardware will perform those operations. Then kernel will send a feedback or an output of some sort. It goes to the operating system to the virtual machine via the hypervisor. So it's a long journey. In type 1, you don't need to follow this long process. So because we have direct hardware access, we reduce context switching. I'll explain you what is context switching when we come to the CPU part. Oh, sorry. Yeah, I'll explain you context switching when we come to the explanation of the virtual CPUs. And anyways, coming back to Cube's OS, it's very cool because what happens is that when you open, let's say, a tab of Chrome, and then you open Microsoft Teams in CubeSys, all these programs start up in their own separate virtual machine. Like you do not need to create a virtual machine, but by default, its behavior is such that it it up into a separate virtual machine. This is extremely secure, and lot of security professionals use this. And I forgot the guy's name, but uh, I think he was responsible for WikiLeaks. It was a very big, you can say, whistleblowing event in the world, and I forgot his name. Anyways, you can Google it. He also used to use CubeSys. I do not know what he does now. I think he moved to Russia or he's stuck in Russia. So, if you have made it till here, you can comment it. It would be interesting to see that how many of you all pay attention. Coming back to the topic, the second type is hosted hypervisor. We all have used uh, VirtualBox, which is a hosted hypervisor. Uh, what happens is that I have already explained. There is an operating system layer that stands between the hardware and the hypervisor. It is the most generic type of hypervisor that is most commonly used in the world. So they run applications on top of a general purpose host operating system that relies on the kernel for your device drivers and scheduling. Okay, again, this is the opposite point. That one was efficient. Now, since there is an operating system layer in between, this is less efficient, but it still works. It is also used. So, I have mentioned CPU, memory, storage, network devices, and other things. Real or fake doesn't matter, but let's see what is or what are these things that the virtual machine uses, which are managed by the hypervisor. So, why we need to understand all this is because understanding each component will explain you uh, or give you knowledge about how you can troubleshoot issues in the future. Let's say a VM is slow or there is some kind of error, network error. We'll speak about errors in the end. But just to explain, if there are such events that occur, if you have knowledge about these things, it will help you to troubleshoot the actual issue. So first component would be a virtual CPU. A virtual CPU is again just a CPU that is created by the hypervisor software that a virtual machine uses. CPU scheduling, yes, I had promised that I'll explain this. No, I mentioned context switching. Anyways, CPU scheduling, and you have also memory scheduling. What happens is that these are some kind of algorithms that allow you to multitask because at root level or the hardware level, what happens is that your CPU can only focus on one task or one process at a time. Why is this big? First, you might say that no, but I have my OBS here and I am also using Google Slides. I have a download going on in background. So how are all these things working one at a time? I'm multitasking here. So there might be multiple things that are running at the same time, but that is wrong. What happens is that if you had to actually multitask all these things at the same instant of time, you will have to use more than one CPU. So generally, modern laptops like mine at least have only one CPU, and what goes on is that uh, there is something called as context switching. Context switching is basically just as it sounds or as it means. We focus on one task at a time, and then there are some algorithms like the time sliced based or fair share based, uh, first come first serve, shortest job first. You have round robin. There are multiple algorithms. If you have studied operating system in your university, you might have heard about these things. If not, I highly recommend you to read about these algorithms. It's interesting, but it's fine if even if you don't know about them because that's not related or relevant to our today's presentation. But these algorithms are basically to uh, improve CPU efficiency. Uh, its time is not wasted. It always has something or the other to perform or to work on. So these algorithms can be different, and your operating host operating system might use different kind of algorithms or processes or workflows. All these conversions are handled by the hypervisor software, privilege handling, and vCPU technology. These things are something again handled by the hypervisor. You don't need to remember these things. Uh, it's just that I've written them. If you are really into it, you can Google about these things. Uh, what happens in privilege handling is that there might be certain kind of priority to every task that takes place. Priority based scheduling is another algorithm for uh, scheduling algorithms for both memory and CPU. Anyways, it's just that we need to focus on more important tasks at uh, as early as possible and the less important tasks at the end. So next component is virtual memory. Now, there are two layers, guest virtual memory to guest physical address and the host physical address. Again, like I mentioned, we are creating the fake CPU, fake memory, or emulated would be a better word for that. But in the end, if you are really storing something, it has to be stored somewhere. You cannot just imagine that it's there, right? So it's translated or brought down to your actual RAM or your actual storage space. This is again done by hypervisor. Uh, so it goes from your guest virtual address. Virtual addressing is another way to maximize your uh, RAM capacity. So it breaks down your full available memory into chunks, and there are multiple concepts again behind this, such as paging. There are again algorithms for paging as well. Anyways, so it translates to the guest physical address, which would be a virtual address, the RAM of your virtual machine, and then it's translated to your actual host physical addresses. So the next component is virtual disk and image formats. Virtual disks are your the emulated storage spaces, the permanent storage spaces. This is the non-volatile part. The volatile part would be RAM, which means that if you shut your PC down, everything in your RAM is just gone. But yeah, your physical storage has persistent memory, so it remembers or it stores the things that you had stored in it. There are again multiple formats. We need to provide the best throughput, which throughput means to complete more operations or more tasks at the same time. And again, these things are handled by hypervisors, so hypervisors are amazing. Your This is an important point, that all the input output paths or directories that are in your guest file system, let's say slash var slash html slash kml, that we have seen the path where your kml files are stored. It is translated into a guest block driver, and then it's converted into some kind of virtual driver, and it's translated in by hypervisor to your host file system or your block device. In short, it just means that from your virtual storage to your actual real physical storage. Oh, our next hardware point would be virtual NICs and drivers. This is important because there are a lot of errors that revolve around this part. For Liquid Galaxy perspective, I have also made a lot of mistakes in this configuration. So drivers are the piece of software that interact with the hardware. Let's say you have a mouse. My mouse, it won't come here. Let's consider my keyboard. Now, when I press a buttons, let's say space, enter WASD, these things are appear like the letters appear on my screen as WSD and space, but at the keyboard level, these are just electrical signals. So these electrical signals are translated by my laptop uh, in the form of an input, which was the keys that I press. This conversion and all this logical part from the hardware to the software and software to the hardware is handled by your device drivers. Now, NIC is Network Interface Card. NICs are responsible for the networking activity of your machine. So it is important because Liquid Galaxy system requires a lot of network configuration. Not a lot, but it does require some good amount of. network configuration, and if you mess it up, uh, there is a lot of uh, troubleshooting that you need to do. So, what is NAT and these things? I'll explain you in the coming slides. First, let us understand the difference in VMs and containers. This popped up in the discussion on Discord. That's why I'm putting it here. So, containers, you can consider Docker as a popular containerization platform. What is different in containers from virtual machines is that there is no guest OS part in containers. So, you can consider these three colors. Oh, my mouse is visible. Yes, these things you can consider as an isolated container: container 1, container 2, and container 3. And uh, container engine, here you can again consider Docker engine. What it does is it does things similar to a hypervisor, but it is using your host operating system itself. So I have Windows 11, so my Docker engine would use my Windows 11 and my actual hardware to perform any kind of tasks that these containers request or uh, required to be performed. And in case of hypervisor, it would be the guest operating system that does all these things. So this is the difference between VMs and containers. And coming back to the NAT networks, so these things are very important again. Now, core concept is that virtual NICs, virtual switches and bridges, NAT tables, DHCP requests, and virtual routing, these things are performed when we are creating the host-only network and NAT network for our virtual machines. Then we connected the adapters to them. Let us begin with understanding what NAT is. NAT is Network Address Translation. It is basically a process in which you have different kinds of machines or multiple machines, like as shown in this diagram, connected on your network. And in the end, it's just LG1 that communicates with your uh, mobile application. So what happens is that NAT, network address translation, is responsible for all this kind of communication that takes place in between the devices. Like when I move something, my earth on LG1, the LG2 and LG3 is earth. The earth in that part also moves, right? So this data sharing is possible through the NAT networks, and the connection between LG1 and your mobile application would be through the host only network. There is a diagram on the next slide which will help you understand host only networks better. Talking about DHCP, it is Dynamic Host Configuration Protocol. Now, DHCP, uh, a good example to understand DHCP is when you created your NAT network on VirtualBox. You assigned or you enabled an adapter on every virtual machine and you attached this NAT network through that adapter, right? Then when you run ifconfig on every virtual machine, you observe that there is an IP address that is associated to that particular machine, right? But if you remember or recollect, we did not assign any kind of IP address manually to any of the machines. How they got an IP address? It is because of DHCP. It basically assigns IP addresses to the devices on your network automatically. You can also configure them manually, but generally DHCP does that for you. So this is the diagram that I mentioned. The router 2901 would be your host only network. So you attach your LG1 to your host only network adapter. Basically, it is kind of a public facing side of your internal network. So LG1, LG2, and LG3, these three machines would be connected. In this case, PC01 and 2 to be specific. These are interconnected via a NAT network, and you have the public facing part, which is the connection of LG1 to this router, and this enables the mobile applications that we make to connect to LG1 and to send and receive data from that particular machine. So, load balancers are another topic that make use of this kind of system, which would be like, let's say you go to Amazon.com, uh, there is some kind of server which is sending you data and you are sending data to, right? But you won't directly ever be able to access direct servers of Amazon. That is because there will be something called as a load balancer in between. Load balancer would share uh, the load actually, it as easy as it sounds. So it will divide or distribute the requests, inbound traffic requests that come to Amazon, and whichever server has the least amount of load would probably handle those requests. Well, it's just a theory that is simple. I'd like to correct myself. In actual Amazon level scale, it would be very complicated. Like, that's why system design engineers are there. Coming back to our topic, why contributors must understand these network is for reproducibility, faster debugging, for prerequisite tasks, these things are required. So having knowledge of all these concepts would be very beneficial. And again, for collaboration, the work on my machine problem would be solved in a better way if you knew all these things. Now, common pitfalls in task one. Uh, for me, I made the mistake of point number one and point number four. Let's go one by one. Which is first is the forgetting port forwarding. What happens is that when you try to connect your mobile application to your LG1, it will say connection time dot, which just means that I am unable to reach that network or that network does not exist. This is because we did not port forward it. Port forwarding I had explained in my first video. You can go back to that, but I'll explain it again, which would be to map your LG1 IP address, internal IP address, to your host only network's IP address. So any request that you make to the host only IP would be automatically forwarded to your LG1. If you do not do that, it won't be able to communicate. Next point is that guest has no internet due to host firewall blocking. So a lot of contributors also faced this issue uh, that I read in Discord mostly. Yes, what happens is sometimes the operating system would block network requests from unknown sources. Generally, it does not, but if it does, you can add an exception on your firewall to solve this. And third issue is about host only network used without NAT. Again, if you are just connecting to your LG1. A lot of people had that issue that LG1 works. Sometimes LG2 or 3 don't work. It's just a blank screen, a black screen, or it does not sync at all. It's an independent earth on every display. This happens because there was something wrong with your NAT network. Next, last point would be that there are multiple NICs that you have created and they could be in wrong order. I what I had done is that when I was trying to port forward, I created multiple NAT networks, and every machine was on a separate network in itself. So it caused a lot of conflict. So to solve this, always ensure that you are following the steps that are mentioned in the videos or in LGB key. And that was all for my presentation, and I hope that you learned something new today. Thank you for watching.